delta into y1. So similarly, the third order finite difference is represent delta cube into y0 is equal to the difference between delta square into y1 minus delta square into y0. So just listen here, the entries of the first leading entries and to go to the top of the entries is said to be the forward leading entry y0 delta into y0 delta square into y0 delta cube into y0. These said to be the forward leading entries, the first order, or simply it can be represent leading entries of the forward method. So similarly, y3 delta into y2 delta square into y1 delta cube into y0, these are said to be the leading entries of the backward differences. So that's what I'm going to represent here, y0 delta into y0 delta square into y0 delta cube into y0. Similarly, y3 delta into y2 delta square into y1. So similarly, I'm going to represent here the backward difference. Backward difference is defined the function nabla. It can be represented. We can't say this is delta. This is the inverse procedure of the delta is nothing but nabla. So f of x be a given function and h is the difference of the interval. Then the backward difference nabla is defined as here. Nabla into f of x is equal to the function f of x minus f of x minus h. So just we have to understand the difference between forward and backward. So backward is represent delta into f of x is equal to f of x minus h. The delta of f of xn is equal to f of xn minus, just we have to subtracting h values only for the backward value. F of xn minus f of xn minus h. So it is also represented the function of yn means delta into yn is equal to yn minus 1. So f of xn minus 1 is equal to, it is represented in the form of function y. Nabla of yn minus 1 is equal to yn minus 1 minus yn minus 2. So etc. Here, nabla of y2 is equal to y2 minus y1. So nabla of y1 is equal to y1 minus y0. So similarly, I'm going to represent in the second order backward difference formulas. Nabla square into yn is equal to nabla into yn minus nabla into yn minus 1. Nabla square yn minus 1 is equal to nabla into yn minus 1 into nabla into yn minus 2, and nabla square of y2 is equal to nabla into y2 minus nabla into y1. These represent the second order backward difference, and these are the first order backward difference. So from that points, I'm going to represent here the backward table. So as it is same here, that is the values of equidistance value for the given thing, the x variable, and this is the y variable. So corresponding to the terms, y0 is equal to f of x0, y1 is equal to f of x1, y2 is equal to f of x2, y3 is equal to f of x3. So the nabla of y, the first order or first finite difference of the backward terms here, nabla into y is equal to the difference between again here y1 minus y0. Nabla into y1 is equal to y1 minus y0, and nabla into y2 is equal to y2 minus y1. Nabla into y3 is equal to y3 minus y2. So just we have to define here the forward and backward. Only difference is the term, in forward term here f of x plus h minus f of x, but in the backward term here f of x minus f of x minus h. That is the major difference between the forward and backward. From that point, I'm going to represent here the table. So like this, the upper entries of the given table is said to be the leading entries of the backward, and the given terms is said to be the leading entry of the forward and backward terms. So this is some basic notations or basic note for your finite differences for backward as well as forward differences. So next
Sir,
I'm
can you
going.
repeat backward difference, sir?
What?
Backward difference, can you repeat?
Yeah, listen. This is said to be a backward difference. It is denoted by nabla. So the function is defined. Nabla of f of x is equal to f of x minus h. But forward means what? Delta into f of x is equal to f of x plus h minus f of x. Just try to understand here. Delta in nabla into f of x is equal to f of x minus h. And from this point, from this governing equation, in these equations, we represent here delta into nabla into y1, nabla into yn minus 1, and nabla into y2. So increasing to decreasing way in the backward form. The forward form is decreasing to increasing way, isn't it? Ascending order to descending and descending order to ascending terms. So from this point, I'm going to represent here the second order second order backward difference formulas. So that can represent square term. Nabla square yn is equal to nabla into yn minus nabla into yn minus 1. Nabla square of yn minus 1 is equal to nabla into yn minus 1 minus nabla into yn minus 2. And similarly, nabla square of y2 is equal to nabla into y2 minus nabla into y1. From this point, I'm going to just try to represent here in the form of table. So that is the difference between forwarded as well as the backward finite differences. Next, I'm going to go on for that. Yeah, wait. That is complete. Wait 1 minute. I will make it. Yeah, are you hearing me? Hello, hello.
Yes, sir.
Yes,
The
sir.
is this
Yes,
working?
sir.
This is slide is visible now.
Yes, sir.
Yeah,
Yes,
listen,
sir.
listen, listen.
Yes, sir. Visible, sir.
Yeah, backward. Let us go to one problem here. Listen. So construct a finite difference table. Finite difference is both backward and forward. Okay. Construct a finite difference table for the function f of x is equal to x cube plus x plus 1, where x takes the values of 0, 1, 2, 3, 4, 5, 6. Identify the leading forward and backward difference. Just try to understand the given problem. Actually, the given problem here, let us we have to suppose the function f of x is equal to one polynomial function. Okay, are you clear? Hello?
Yes.
Yeah, this is one polynomial function where x takes the values. These the values for f of x. That means to say f of x means what? The corresponding values of y0, y1, y2, etc. Are you clear? So here f of x is equal to x cubed plus x plus 1. So that is the given thing. But using these values of x values, put x is equal to 0. So f of 0 is equal to 1. F of 1 is equal to, just we have to substitute in place of x is equal to 1. We get f of 1 is equal to 3. And here put f of 2 is equal to 11 and f of 3 is equal to 31. F of 4 is equal to 69 and f of 5 is equal to 131 and f of 6 is equal to 223. Isn't it? So these are the values of y0, y1, y2, y3, y4, y5, y6. Already I said that here the function y is equal to f of x. Yeah, y is equal to f of x. That's what I said here. So y is equal to f of x. In that way, we are going to define here y of 0 is equal to y0 is equal to 1, y1 is equal to 3, y2 is equal to 11, y3 is equal to 31, y4 is equal to 69, y5 is equal to 131,
So
y6
there's
is
no
equal.
problem on the screen.
Yeah, just listen.
Sir,
So
no problem on the screen, sir.
now you didn't see here.
No,
There's no.
no, sir.
There is a
We
concept on the
can't
screen.
find any problems, sir.
Yeah, wait. Wait 1 second. So
Now, sir. It is
wait, this is not forward and backward formula. Yeah, you write your name and USN for the chat box one by one. I will share that one. Just write your name and hello.
yes, sir.
Just write
Yes,
your
sir.
name and
Sir.
your USN number
Yes,
one
sir.
by one,
Yes, sir.
one
Yes,
by
sir.
one, one by one. You
Okay,
have to do it. I will share now.
okay, sir.
Yeah. Yeah, now is visible now. Listen, look at that screen. Hello.
Yes, sir.
Yeah, listen. So this is the given table. So given problem, the function f of x is equal to x cube plus x plus 1. Using these values, we have to find y0, y1, y2, y3, y4, y5, y6. So next I'm going to represent in the form of table. Look at this table. So these are the values of the x values 0, 1, 2, 3, 4, 5, 6, and corresponding value of y is equal to, what are the values of y? Tell me one by one. What is the corresponding?
1, 3.
1, 3, 11, 31, 69, 131, and 223. So these are the values of corresponding values of y. So what is the first forward difference now here? Just we have to
3
subtract.
minus 1.
Yeah, 3 minus 1, that means to say 2. And second term here, 11 minus 3 is equal to 8. And 31 minus 11 is equal to 20. 69 minus 31 is equal to 38. 131 minus 69 is equal to 62.
62.
Yeah, 223 minus 131 is nothing but 92. These are
92.
these are all first order finite difference. Similarly, I'm going to represent here the second order finite difference. 8 minus 2, 6. 20 minus 8, 12. 38 minus 20, 18. 62 minus 38 is equal to 24. And similarly, 92 minus 62 is equal to
30.
yeah, 30.
30.
That is the second order finite difference. As it is, we go for the third order finite difference here. 12 minus 6 is equal to 6. 18 minus 12 is equal to 6. 24 minus 12 is 18 is equal to 6. 30 minus 24 is equal to 6. So this is the third order finite difference. After that, we have to do all the zeros terms. Fourth order, fifth order, sixth order, all the zero terms. Our aim is to represent up to the finite difference. The highest power of forward difference would be 0. Then here the third order forward difference is 6 only. The fourth order should be fifth order and sixth order. All are 0 term. Just we have to leave it now. So after that, our aim is to find out the leading forward entries and leading forward backward difference and leading forward differences. So the leading forward differences means the upper term 6, 2, 6, 6, 0, 0 terms here. Delta into y naught is equal to 2. Delta square into y naught is equal to 6. And delta cube into y naught is equal to 6. And delta power 4 into y naught is equal to 0. Our leading forward difference, just try to understand what I said in the first slide. The same thing here. So the upper entries of the each table is said to be the leading entries of the forward difference. Similarly, the lower entries of the given table is said to be the backward differences. Here, the leading entry delta into y naught is equal to the last term 92. Delta square into y naught is equal to 30. Delta cube into y naught is equal to 6. And delta power 4 into y naught is equal to 0. Like that, this is the leading entry for the backward difference. So just try to understand what is the forward means. That can be represent f of x is equal to f of x plus h minus f of x, and the backward means f of x is equal to f of x minus h. So the leading entries should be the uppermost elements are the leading entries for the forward difference, and the lower entries for the given tables are backward difference, leading entry for the backward difference. Are you clear? Are you clear, or I explain once again? Hello?
So explain once again, sir, from starting.
What?
From the sum.
This sum.
Sir, from starting part,
From?
sir.
From?
Starting part, can you explain once again?
Listen, the starting part is there is no here. No, just try to understand. Forward means the formula. Delta into f of x is equal to f of x plus h minus f of x. From this formula, I'm going to define here delta into y naught, delta into y1, delta into yn minus 1. These are all first order finite difference. So the second order finite difference means delta square into y naught and delta square into y1, delta square into yn minus 2. Okay. So just I'm going to represent in the table here. X naught, x1, x2, etc. xn minus 1, and y naught, y1, y2, etc. yn minus 1. And delta y means you can represent difference between y naught, y1 minus y naught, y2 minus y naught, like that. And similarly here the backward difference, the term nabla to f of x is equal to f of x minus h. From this given equation, I'm going to define here nabla into y1, nabla into yn, that is equal to yn minus 1, nabla into yn minus 2, nabla into y of 2, nabla into y1. So these are all the following terms. These terms can be constructed in the form of table here: x, y, nabla into y, nabla square into y, nabla cube into y, nabla to the power of n into y. This is the forward as well as the backward term. The uppermost integers are the leading integers for the forward, and the down integers are the last integers or the last integers of the given table are the leading integers for the backward differences, isn't it? So next I'm moving on. The interpolation. Interpolation is nothing but the method of finding the values of y at the specified values of x. So having known values of x and y is called interpolation. Here, just we have to finding the values of y at specified values of x. That means to say, to find the values of y by using the values of
Sorry,
x.
your voice is cutting.
Now, are you here? Hello?
Yes, sir.
Yeah. So interpolation means just we have to finding the values of y by using the specified values of x. Having known values, these two are known values of x and y is called interpolation. So the first condition should be the values of x is near beginning to the table, then we have to use Newton's forward interpolation formula. So that means to say here, any values of x was near to beginning to the table. Beginning to the table, just I'm going to explain in the next problems. So beginning to the table, then we have to use the Newton's forward interpolation formula. Similarly, if the values of x is near end of the table, then we have to use the Newton's backward interpolation formula. I will explain what is this in the next problem section wise. So next I'm going to define here Newton's forward interpolation formula, or it is also called Newton's Gregory forward interpolation formula. Just you have to try to understand the formula here. Y is equal to y naught plus p into delta into y naught plus p into p minus 1 upon 2 factorial into delta square into y naught plus p into p minus 1 into p minus 2 upon 3 factorial into delta cube into y naught plus etc. This expression is said to be Newton's forward interpolation formula. Just try to understand. This is here the functions are said to be y and p. So what is the meaning of p means? So where p is equal to x minus x naught by h. So here x is nothing but the values of x at which y has to be calculated. So what I'm saying is, so x is the values of x at which y has to be calculated, and x naught be the initial values of x. This is the initial value. X naught is nothing but initial values of x, and h is equal to the common difference or step length. Already I said in first semester also, h is represent the difference between two equidistant points, or simply it is also called h is equal to the common difference or step functions, and this notation is represent the forward difference operator. In place of this nabla, that means to say the backward difference operator. Try to understand what I'm doing here. Here the function Newton's forward interpolation formula is represented like this: y is equal to y naught plus p into delta y naught plus p into p minus 1 upon 2 factorial into delta square into y naught plus p into p minus 1 into p minus 2 upon 3 factorial into delta cube into y naught plus etc., where p is equal to x minus x naught by h. X is nothing but the values of x at which y can be calculated, and x naught is nothing but the initial values of x, and h is nothing but the common difference, and delta is represent the power difference. So similarly, the backward interpolation formula, the Newton's Gregory backward interpolation formula is represent y is equal to, in forward the first function should be y naught, but here y is equal to yn plus p into nabla into yn plus p into p plus 1 into 2 factorial, but in the forward difference is p into p minus 1, but in backward here, yeah, in backward here p into p plus 1 by 2 factorial into nabla square into yn plus p into p plus 1 into p plus 2 upon 3 factorial into nabla cube into yn plus etc. Where p is equal to here x minus xn upon h. So x is same thing here, the values of x at which y has to be calculated, and yn is equal to the final values of x. So here the in forward formulas here, in forward here x naught is initial values of x, in backward here backward final values of x, and h is yeah, h is nothing but the common difference, and nabla is represent the backward difference operator. So just try to understand the algorithm or problem here. Listen, find the values of y of 0.12 given the data. So that is the data for x and y. X is equal to 0.010. Corresponding value should be 0.1003. Let the x value 0.15. Corresponding values of y is equal to 0.1511, and x is equal to 0.20, y is equal to 0.2027, x is equal to 0.25, and y is equal to 0.2553, x is equal to 0.30, and x is equal to 0.3033. Just try to understand here, since x is equal to 0.12 is close to first values of x, isn't it? Of course, here the values should between here in place between 0.10 to 0.15, isn't it? So x is equal to 0.12 is nearer to the first values of x. So first values of x, hence we have to apply Newton's forward interpolation formula. Are you clear what I'm saying? Hello? Hello?
Yes, sir.
Are you clear?
Yes, sir.
Just try
Yes,
to
sir.
understand. Yeah,
Yes, sir.
x is the point of 0.12. So 0.12 is nearer to the first value 0.10. So therefore nearer to 10 means according to this point, already I said here, listen, in this point, the values of x is nearer to beginning of the table, then we have to use Newton's forward interpolation formula. Okay, if the values of x is nearer to end of the table, then we have to use the Newton's for backward interpolation formula. So from this first point, we conclude that in this given problem, we have to show that, or we have to find by using the Newton's forward interpolation formula of the term y of 0.12. Are you clear? So therefore, we have to construct a Newton's forward interpolation table here. So these are all the given data. X is equal to 0.10, 0.15, and 0.20, 0.25, and 0.30. The corresponding value, how to find out here? Already the corresponding values are also given in this table here: 0.1003 and 0.1511 and 0.2027 and 0.2553 and 0.3033. Then how to conclude what is the step value here? What is the step function? What is the value of h? Anybody? Hello? 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 And what is the value of h here? H is equal to what? Anybody tell me what is the value of h here? What is the step value?
0.05.
Sir, 0.05.
0. Point,
Say 0.05.
0. Point.
0.05, sir.
Yeah, good, good. So therefore, delta into y for the first value here, 0.1511 minus 0.1003. The difference would be 0.0508. Similarly, the 0.2027 minus 0.1811, we get 0.05168. And similarly, 0.2583 minus 0.2027, we get 0.2326. And 0.3098 minus 0.2533, that is equal to 0.054. Using this formula, just we have to difference of lower to upper, lower to upper, lower to upper. Then we get delta square of y, delta cube into y, delta power of 4 into y. So therefore, Newton's Bagory finite interpolation formula is represent y is equal to y naught plus p into delta y naught plus p into p minus 1 upon 2 factorial into delta square into y naught plus p into p minus 1 into p minus 2 upon delta 3 cube into 3 factorial into delta cube into y naught plus etc. So we know that p is equal to x minus x naught upon h, that is equal to 0.12 minus. So what is the value of x here? Already here the
0.12.
yeah, because already in the given problem here x is equal to 0.12. That's what I am going to say. Our aim is to find out y of 0.12. So therefore x is equal to, easily we have to say x is equal to 0.12. X naught is equal to, that is the point nearer to what is the value of x naught here?
0.10.
0.10 the first.
Yeah, that is the first point for x naught, that is equal to 0.10, and the step function should be 0.05. So that is equal